Now we're going to do problem number 3 from our Chapter 9 review. A health insurer has determined that the reasonable and customary fee for a certain medical procedure is $1,200. They suspect that the average fee charged by one particular clinic for this procedure is higher than $1,200. The insurer wants to perform a hypothesis test to determine whether their suspicion is correct. The mean fee charged by the clinic for a random sample of 65 patients receiving this procedure was $1,200. Do the data provide sufficient evidence to conclude that the mean fee charged by this clinic for this procedure is higher than the $1,200 that is considered reasonable and customary? Perform the appropriate hypothesis test using a significance level of 1% and assume that sigma, or the population standard deviation, is $220. And we want to do this test using the p-value approach, and make sure you show your 6 steps with your formulas and the variables. And a picture may help you get the correct p-value. At the end, state the strength of your evidence, which of course will be based on the size of your p-value. So just like in the critical value approach, we're going to need our 6 steps. First step will be stating our hypothesis, then the alpha or significance level, then getting our test statistic, and since it's p-value approach, the next thing will be getting the p-value, which of course comes from the test statistic. Then you decide if you're going to reject or not based on that p-value, and then interpret your answer at the end. Okay. So I'm going to write down the variables we're going to need to help us complete this. So looking at this problem, I'm going to pull this out first. We have a sample size of 65, and from those 65 patients, the sample mean was 1280 for that procedure. The mean you're testing it against is the 1200. That's the reasonable and customary amount that the insurance company had defined. We want to do this test at the 1% significance level. Now be careful, because 1% is 0.01, right? Not 10. 10 would be 10%. So 1% is 0.01, and we have the population standard deviation, or sigma, which is $220. So this is going to allow us to do a Z-type test because we have the population information. So step number 1, we're going to define our hypotheses here. And our null hypothesis is always that the mean equals some established amount. And in this case, the established amount is the $1,200. And the thing we're testing, remember, is the company is concerned that this one clinic is higher than, so they're worried about greater than. So they're worried about greater than 1,200. So this is going to be a right-tailed test. Right-tailed test. All right. Step 2. State our alpha or significance level, which we're told we want to do this at the 1% significance level. Step 3, we need to get our test statistic. In this case, it'll be a z-test. Okay, so we need to convert our x bar to a z-value, convert x to z, using this equation here, which is on your equation sheet. So now we have the equation, so now we just plug in from our little table of information here variables, we can just plug in the numbers. So we've got 1280 minus 1200 over sigma, the population standard deviation, which is the 220, divided by the square root of 65. And a couple parentheses here might help you out with your calculator. So if you do that correctly on your calculator, you should get 2.93. Okay, this is our test statistic. If this was the critical value approach, this would be a dot on our picture, but it's not the critical value approach. Instead, we're going to take this number, this z value, and we're going to convert it to a probability. So this is our test statistic, and we're going to get the p-value from it. We have to figure out the probability of that test statistic. So the p-value is the probability of our test statistic in this case. Since it is a greater than test, the probability we're interested in is the probability that we're greater than that test statistic. Okay, so if we drew a picture to help us out here, again, this is a picture of z, and we plotted 2.93 on here. The probability we're interested in, because it's a right-tailed test, is the probability that we're greater than that test statistic. So this is the probability of our test statistic, which, since it's a right-tailed test, will be the p-value. So when we look up this 2.93, when you look that up, of course, you'll get, 0.9983. That's not what we want, right? We don't want below it. So we need to subtract that number from 1 to get the probability that we're on the right side of it. And that will give us 0.0017. So our p-value equals 0.0017. That's a pretty low number. All right, let's get a little more room for ourselves. So now the next step, so let's see. So we've done step 1, 2, 3, 4. The next step is we have to decide if we're going to reject or not. What criteria do we use for that? Well, when we're doing the p-value approach, the criterion we use is if our p-value is less than or equal to alpha, then you're going to reject the null. This means you just got something very rare, too rare to be random variation in your opinion or in your study here. So you decide that you're going to reject the null because you just got something very rare that seems to be beyond normal random circumstance. Then you would reject the null. Otherwise, if the p-value is greater than alpha, you consider that to be normal variation, so you don't need to reject the null. It's a normal variation situation. So let's look at what we have now, p-value here. So our p-value is 0.0017. And remember, the alpha we were using in this case was 1%, 0.1. So look at this, 0.017 is certainly less than 0.01, right? Because you have an extra 0 in here, right? So 0.001 is less than 0.1. So this definitely is a case where you're going to reject the null. And if we reject the null, that means we're going to use the alternative, whatever that is. So to interpret this correctly, let's remind ourselves what the alternative was. In this case, the alternative, so we're rejecting the null, we're embracing the alternative here, and the alternative is that the price, this was dollars, of the procedure at this clinic is greater than $1,200. So our test just proved that it was significantly greater. So this particular clinic is charging a price that's greater than what they consider to be reasonable and customary. So this is our short answer right here. So let's do our full interpretation. This was done at the 1% level. You always want to lead with that. So at the 1% significance level, the data does provide, because we're going to reject, so it did provide enough evidence to reject the null. The data does provide enough evidence to reject the null hypothesis, So we can say, basically, that they're charging more, right? We can say the mean fee, remember it's always the mean we're looking at, the mean fee charged by this clinic is more than $1,200. So at the 1% significance level, the data does provide enough evidence to reject the null. We can say the mean fee charged by this clinic is more than, that's what we were worried about, $1,200. So the last part of this, the very last part, don't forget, was what is the strength of my evidence for this rejection? I just said I got significant evidence for rejection. How strong of an evidence was it? Well, based on the p-value, look at your p-value, because p equaled 0.0010. This is very strong evidence, very strong. Why? Because our p-value or because 0.0017, right, 0.017 is less than 1%. So the definition of very strong is any p-value less than 1%. So since our p-value is less than 1%, we have very strong evidence for rejection in this case.